Hello everybody and welcome back. Today I'm going to teach you how to do Winston from Overwatch. So in this tutorial we are going to do the main two power-ups or abilities from his character. So let me show you what this tutorial is going to be about. So when I'm going to press my left shift button, I'm going to jump into the air, as you can see, and this is pretty nice because this way you can jump or ledge to the other, or whatever you want to do with it. And the second one is a shield, which you can place down. As you can see, it's like a barrier, and I have two types of fire modes. So one is going to be for the allies and one is going to be for the enemies. So let me spawn this one more time. So then I'm going to fire with the ally system, and then I'm going to fire with the enemy system. So as you can see, these bullets or line traces were blocked by the sphere. And one more thing that I want to show you is that they are going to get blocked out here as well, so you're not going to be able to shoot from inside to the outside, exactly like it is in the game. And one more thing that I have right here is an arrow that is going to indicate the forward vector of my character. And yeah, so actually let's just begin. So first let me show you so this is the blueprint, and let me show you how you can do your jump. So what I have here is an input action mapping binding to my left shift key. Every time I'm going to press it, we are going to do a branch right here. We are going to check if we are falling. So in order to do that, drag your character movement in the event graph, then get from there is falling and plug that into the condition. If it's false, we are going to do another branch. So this is going to be a variable, so a boolean, and we are going to use this a little bit later. So this is going to be used to check if you have actually jumped or not in the past 5 seconds. Okay, then if we can use jump, then we are going to launch our character. So here what we want to do is go into our viewport and add an arrow. So make sure that this arrow is not attached to anything but the character, so make sure it is in the capsule component, which is inverted, and make sure it is going to be like in the way that the camera is going to be facing. So it's going to be actually the same way, the same forward vector which the camera has. But the reason why we are not using the forward vector of the camera is because if we would be to attach this arrow to the camera, once you are going to rotate the camera, the arrow is going to go in the ground, which is not what we want, because actually let me show you. So I'm going to reattach that there, and if we are going to point at the ground and then jump, as you can see here, we are only going to jump in the air. We are not going to jump forward. This is not what we want. We want to jump forward wherever we are pointing. Okay, so after we have added our arrow in the viewport, then we need to get the forward vector of the arrow. Then from there we need to split the struct pin. So when you're going to get this node, you're going to have like this, the return value. From there, right click and split the struct pin. Then get your X and your Y value, I think those were the ones. So yeah, get your X and the Y values and plug them into a float multiplied by another float. So my values are 1000. Remember, you can change these values as much as you want, so they are going to fit your game. Then what we want to do is to get our launch character, and again, by default, we are going to have here like this, a vector, but we want to split the struct pin as well. Then what we want to do is to get the first float multiplied by float from the X one and plug it into the X, and then the second one from the Y, plug that into the Y. And then in order to set how much in the air you're going to be launching, you need to put here a value. Mine is 800. If it would be, let's say, 2000, and then I would play, then as you can see, I'm going to go pretty high in the air. So back to 800. Okay, after we have launched our character, we are going to set the variable can use jump to be false, and then we are going to set it to be true after 5 seconds. So we are not going to be able to spam our left shift key. Okay, so this is pretty much all for the jump boost. Now let me get back, actually go to the barrier. So as I've shown you, here is the barrier. So let me show you how I've did it. So this is the material. Actually, no, this is the material. It's a pretty simple one. I can't really explain what I've did here because I'm not really experienced. If you want to learn more about these nodes here, you can Google them up. There is some documentation about them in the official documentation, but I'm going to try my best to explain them. So, what we are going to do here is that we are going to have a linear interpolation. Actually, no, let's start with the material. So, here we have our material domain. We need it to be a surface. Then the blend mode needs to be translucent so we can access the opacity node. Then we have the shadowing model, which should be unlit. If this is going to be default lit, it's going to look like this. Looks pretty much like the same, but I prefer using the unlit. Okay, then what we want to do is to get a linear interpolation and then get two constant tree vectors. So the first one can be whatever color you want. The second one can be whatever color you want, but the white is going to be the color, as you can see here, around the circle, and at the base is going to be some white. So if I'm going to change this color to, let's say, to red, you're going to say this is going to be now pink, because it's not red, this is pink. Okay, this is more like it. So it's going to be red on the sides and blue inside. So back to white. You can even put black if you want. Okay, then, so plug the blue into the A and the black into the B. Then from the alpha, what we want to get is a Fresnel, which basically has something to do with the reflections and all that stuff. Okay, then we want to get a chip contrast, and I can't really explain this because I don't know how to explain it, but as I've told you, Google it up. Then we need to get a constant and plug that into the contrast. Then we need to get a depth fade. So what this is going to do, based on our camera location, we are going to see the black color around it. Then we need to get a -1, because if we would have this plugged directly into the max here, it would be like this: black everywhere and blue around it. So plug this back here. Then we need to get a max. Again, I can't explain this because I'm not really sure what it does. Okay, and then plug the max into the alpha. Then what you need to do is get another constant and plug that into the opacity. So if you haven't understand what this does, you can ask me in the comments below, and then I can give you the real explanation. Okay, then what we have here is a blueprint called Barrier Projector, because this is how the ability is called in Overwatch. Okay, so what we have here are one sphere, which is a static mesh, and two sphere collisions. Then, so the sphere, the static mesh, is going to have the material that we have just created, and the two sphere collisions are going to be like this. One of them is going to be just a little bit outside of it, so it's going to, as you can see here, a little bit outside of it, and the second one is going to be inside of it. So basically the difference between them is the sphere. Okay, then into the event graph, we are going to have here some variables and some collisions, responses to chance and all that stuff. So let's go back into our character. What we are going to do here is going to create a new variable, which is going to be a boolean, and we are going to make that can inside barrier actually. So then if we are going to get into our sphere 1, which is the sphere outside the sphere, actually let me rename this. So not sphere, this is going to be barrier. Okay, so when we are going to enter the sphere which is outside the barrier, we are going to cast to our character, and we are going to set inside barrier. When we are going to end the overlap with the sphere, we are going to cast to our character to set inside barrier to be false. Okay, so let's go back here and these are the two firing modes, which are going to spawn line traces. So here for the LE part, we are going to check if you are inside the barrier. If you are not going to be inside the barrier, we are just going to spawn a normal line trace. So here we are going to have our camera, get our location, plug that into the start, get the forward vector, multiply that with float, mine is going to be 8000, then add those two values up. Then plug this into the end. So basically this is going to set the orientation of the line trace. Then out of actors to ignore, make an array and make sure you have self here, and here at the function let's add an input, which is going to be an actor, and plug that into the array right here. This is going to help us a little bit later to determine where we want our bullet to go through the barrier or not. Okay. Then we want to have here a return node with an hit result and a boolean called outHit and return value. If you want to do this simpler, what you can do is create that into the event graph and then collapse to a function. Okay, so as I said, here we're going to do a branch and we are going to check if you are inside the barrier or not. So if you are going to be outside it, we are going to just do the line trace, and if we are going to be inside it, we are going to do the line trace as well. But this time we are going to do a branch here, and from the outHit we are going to get a break hit result. Then out of the hit actor we are going to cast our Barrier Projector. So what it's going to do is that we are going to check if we have actually hit anything, and the break hit result is going to check if our hit actor, so if what we have hit is actually the barrier. And if it would not be the barrier, it would cast the fail. It is going to fail the cast. So we are not going to do anything else after this, because it depends now on where you want to destroy something or not and all that stuff. So here you need to add your own blueprint. Okay, then one more thing that I forgot to tell you is that here you need to change the trace channel. And now let me show you why. Here in our Barrier Projector, our barrier is going to have some special collision, and both the spheres as well. So the barrier is going to have two custom trace responses, so actually the spheres as well. So both are going to be ignored at the barrier. The first sphere, which is going to be outside, is going to have the first one blocked and the second one ignore, and then the one that is inside is going to have the ally ignore and the enemy overlap. Now let me show you how you can create those. Go to edit, project settings, then go to collision. So here collision, then make sure you add the trace channel and not object channel. So both should be blocked by default, and then you need to change those into your blueprint. Okay, then let's go back into our character, and here you need to change the trace channel. Okay, then let's go to the enemy part. So here again we need to do a branch if you are inside or outside the barrier. If you are going to be outside it, we are going to do another special function, which the only thing that we are going to change is that our trace channel is going to be enemy this time and not ally. Then go back into the event graph, and out of true we are going to do another line trace, the same type of function. Okay, then out of return value we need to do a branch, and if it's going to be true, again we are going to break the hit result, and then we are going to cast to our projector, to our barrier projector. If we are going to be able to cast, so our cast won't fail, we are going to call another function, which is going to be again different from the both before. So what is different is that my float here with which is going to be multiplied with a vector, with the forward vector of the camera, is going to be 800 and not 8000. The reason for that is because from the center of the sphere to the side of it, it's 800 units, or whatever are the units in our Unreal Engine. Okay, so back here, and then from the actor, make sure you have this here, which is going to help us a lot, because we need to cast the Barrier Projector to be the actor. Okay, so now what we want to do is go back to our Barrier Projector, the blueprint, and go to the second sphere, which is going to be inside. Go and get on component begin overlap. Then out of there, get sphere 1 and get sphere 1, and out of there set collision response to channel. So you can get whatever channel you want and then set the response for it. So normally, by default, this is going to be, for the enemy, is going to be block. Then, so we are going to set it to be ignore, and then after 0.0008 seconds, we are going to set that to be block once again. So yeah, this is pretty much all for this tutorial. Thanks for watching, and don't forget to like the video and subscribe if you learned something new from this tutorial and if you want to see more of my content. And guys, until next time, goodbye.